Hello, everybody out there. No echo, isn't it great? I'm Mike Sokol from RVelectricity, and welcome to our little our live stream all about lithium battery charging. So, without further ado, yeah, we got all kinds of questions coming in here. Well, okay, we're gonna get to a bunch of these here. Let me first introduce Dennis Wieske. Did I pronounce that correctly, Dennis?
Actually, it's Wieske, but
Wieske.
thank you for having me, Mike. Yes,
Wieske, whatever. So,
whiskey. I have one of those too. Thank you. I'm very glad to be here.
excellent. We got all kinds of. I've got Vancouver, Illinois, the snow belt of northwestern PA. I've got like 8 or 10 inches of snow on the ground here. Oh, ugh. So I've been having my little fun. Okay, so let's go ahead. I'm going to go ahead and just go through a little bit about this. Hey, Dennis, can you explain just a little bit about why people are so interested in lithium battery conversions now?
I think the biggest thing that I get, and because I work in the service department, I've been kind of hearing from customers all along. They've wanted to uh, go to the lithium battery, and every year it has just doubled and doubled and doubled. And where we used to get 1 or 2 calls a week, we're now getting 3 or 4 calls a day related to lithium and people wanting to put lithium batteries in their RVs. They're easier to maintain. You don't have to watch the water. You don't have to do anything with that. The posts stay clean. You don't have corrosion. They can charge faster. You can discharge them a lot deeper than you can a lead acid battery. And some people like the fact that they don't have to worry about the maintenance. Some of these batteries are in locations in the RV that are just very difficult to get to, even to take a voltage measurement right on the battery post. They're tucked in away. And so the idea is no worry. Then you have boondockers that like the fact that they have a higher power density for their usage, and they can charge much quicker. Campsites limit the amount of generator time you can run, and 2 hours with a 60 amp charger, you can fill a 100 amp hour battery. You can't do that with a lead acid battery. Just impossible.
Okay, so I've got a couple of questions here coming in that we'll field here in just a minute. Let's see, battery types. Okay, so the three main types of batteries. Let's just go to a PowerPoint here for a second. The three types of batteries that you're going to see in an RV typically are going to be a flooded cell lead acid, what they call FLA, flooded lead acid, an absorbed glass mat, AGM, iron phosphate. And we will note that this is not the same chemistry as the batteries that show up in your vaping cigarette things or the headphones or the hoverboards that have blown up. And they come in a variety of types. I mean, there's 6-volt deep cycle type of batteries, typically flooded lead acid, 12-volt deep cycle, flooded lead acid, AGM, lithium batteries. And there's also a whole series of 12-volt marine/starter batteries like combo batteries, that kind of stuff. So I'm going to just skip through, a couple of other. This is one of the big questions here that we get all the time is, can you simply just drop in a lithium battery into your existing charging system? And will that work? Will you get full usage out of it? So what do you think, Dennis? The guys that just say, just drop one in and don't worry about whatever your charger is that a good thing or a bad thing?
It's not going to be harmful for the lithium battery, but all the advantages you have with the lithium battery as far as capacity and rate of charge, that all goes away if you don't have a sufficient voltage to charge the battery, or you have sufficient voltage and your wiring is too small to allow a high current flow so that battery can charge in a rapid mode. These are the biggest things that we see from people.
So I'm going to put my first question up since we're talking about charging right now. And here this is. Okay, so Mike from Louisville, Kentucky. Will my truck alternator properly charge a lithium battery using the 7-pin connector? Oh boy. Well, I'll tell you what I know about the 7-pin connectors. If you're lucky, they're good for 5 amperes of current. And most of the time they don't run very heavy wire back there in any event. So my guesstimate is no, but there's also things that you can get into trouble even if you do have heavy enough wiring going back there and try to directly connect a lithium battery to your alternator. You want to expound on that a little, Dennis?
Okay, so when you're charging from the alternator, there's a couple things that are happening. If you're going through a 7-pin connector, like Mike said, it's small wire. So that means you're going to have a huge voltage drop from the alternator to the battery. And Mike has a chart that he can display that shows you what happens when you have about a 10%. That would be example number 2, Mike. When you have a 10% loss of voltage going from the battery, from the alternator or the charger to the battery. As you can see, the blue line is your amps, and with a 60 amp charger, we're really only charging at a little above 30, 35 amps. So even though the charger is capable of putting out more power, it's not getting to the battery, and that is because of the loss of a wire. And on a 7-pin, you're looking at the 10 gauge wire. Probably at the best, and then you also have to consider the distance from the wire getting from the alternator to the battery. The other issue you have with the alternators are, yes, there are smart alternators, but they aren't giving you a constant 14.6 charging voltage. So at the lower voltage going to the battery, you may get a small charge. Maybe better than a trickle charge. It'll maintain your battery, which you really don't need to do. But if there's something that's running in the RV, it may supplement power for that, but it's really not effective as a battery charger, especially through the 7-pin connector. Then you have the other issue of, okay, so let me put some 2-aught cable going from the alternator back to the battery. And then you have the reverse problem. Driving down the road, not so much, but that voltage from the alternator can vary. They're smart. They do what they're programmed to do, and you're not guaranteed to have that 14.6 or 14.7 high rate of charge from the alternator. And if you're thinking of, let me use the alternator to charge the battery while I'm here at the campsite. Problem with the alternator is they are self-cooling, which means the fan is built into the alternator, and the efficiency of the fan is dependent on the RPM of the engine. The slower the engine, the more inefficient cooling that's going to take place. If you start drawing 60, 70, 80 amps through that alternator at a slow speed, you're going to burn it up. And that's it. It's toast. And then you're stuck where you're at because you'll have to have somebody come out and get an alternator or alternator replaced. And I'm sure that would be very expensive. There are ways around it, but we can have other discussions on that.
Just as a quickie thing, I've been experimenting with DC to DC chargers. So I've got some product in from RedArc, and basically it allows you to throttle the amount of charging that you want to go through it. Plus, it will accept a second input from like a solar panel or whatever. So I think that it would be a wise thing, even though everybody says, "All you're telling me to do is spend money." The thing is that these are expensive investments in these batteries, and you want to get all the performance out of them without damaging anything. So I got another really good question here. Let's pop this one up here. So Dennis, this should be right up your alley. Gary Nichols, I have an older motorhome with a converter that does not, wow, that's a really big site, does not have a lithium setting. Can I use my solar charge controller to still charge my lithium batteries, or do I have to buy a new converter? So can you use a solar one to top it off? I've had a couple of people ask me, use your regular converter to get it up 3/4 of the way in your solar converter to top it off?
So there's a couple ways you can look at this. With an older converter, the old converters, and we're talking 80s, 90s, they were a fixed voltage converter. In other words, they put out a steady 13.6 volts continuous. Whenever they were powered on AC, they gave you a continuous voltage output. Later on was development of multi-stage charging. Multi-stage charging, the smart systems would sense a battery that was extremely low and apply a boost voltage, and after a period of time would revert down to a slow charge, which you need on a lead acid battery to put a finished charge in them. And then afterwards they would settle down into a float voltage. And so if you're plugged in for a long period of time, they would maintain your lead acid batteries. So when you have an old charger, you really were stuck with whatever voltage that it would produce. So solar is supplemental. 100-watt panel may at optimum give you about 8 amps of charging on your lithium battery, and they do have voltage settings for that. However, if the sun is hidden behind clouds, you're parked under trees, the weather just turns terrible, you're not going to get much use from the solar power, and you will have to rely on possibly a generator and your onboard converter. I have to do a plug for the company here because our chargers do have manual control of the multi-stage charging. So if you have an older charger, say a 9200 series deck mount, or right now any of our power centers, but even some of our older power centers, you had the capability of manually selecting boost mode, which was 14.4 volts, which is a good charging voltage. It'll allow you to fully charge that lithium battery. So people that are relying on solar, don't really want to carry a generator or don't want to use it very much, they don't need to spend the money if they already have the ability to, when they need to, provide that extra voltage from the charger to charge up their lithium batteries. And even if it's for a couple hours, if you can put 60 amps into that battery in a couple hours, or 120 amps into a battery bank for a couple hours, that'll probably get you through the night. It's more than enough power to run a CPAP machine or other medical devices. Although these are not designed for medical use, we have no guarantees on that. But by charging that battery, then you can increase the power availability overnight. That's a key factor.
So let's just talk about generator charging for a bit. I've written a bunch of articles about this, and somehow people get the misunderstanding that you should use the 12-volt charging output of like a Honda generator. And I think at most it's good for 8 amperes and at 12 volts. And in fact, it's not voltage regulated at all. It just does its own thing. And what I've told them to do is simply get your little, whatever your generator is, plug it into your shore power connection. And then even if you're charging, let's say at 80 amperes at 12 volts on your batteries, that only equates to about 1/10 of that, maybe 8 amperes or so at 120 volts. And so a 2,000-watt generator will very easily charge your lithium batteries really at full speed if you just plug it into the 120-volt outlet on the thing and let your battery charger converter take care of it.
Most of that is right on the mark. The 12-volt charging outputs are not regulated. So if your house load, especially on your inverter generators, if your house load is light, your generator speed is low, your output voltage is going to be low, there's going to be really no usable power there. The only way to make any real use out of it is to go to a DC to DC converter and have a regulated output. The available amps will be limited by the generator output at whatever RPM it happens to be running at. Otherwise, if you turn around and just plug your shoreline into the generator, then whatever charger you're using. On a 60 amp charger, you're looking about 8 amps. An 80 amp charger, you're probably looking closer to 11, 12 amps. So that is a portion of that, and that's just a pretty good portion of a 2,000 watt generator. So if you're going to charge your battery on a 2,000 watt generator, you're using half your power just to charge the battery. So you have to consider, am I running the generator so that I can run the blow dryer? Or am I running the generator so I can charge the battery? Because you won't be able to do both at the same time. Once you've charged the battery and you still need use, or you said, okay, I have enough charge in the battery, I don't need to fully charge it. And a lithium battery does not have to be fully charged. Another great thing about a lithium battery, doesn't have to be fully charged. So if you got it up to 75% and you said, oh, well, this is enough to get me through the night, you can turn your converter off and use it for whatever else, cooking, or, that microwave, hair dryer, getting ready for a night out or whatever.
And those are all good points. And a lot of people assume that you've got to charge everything all the way up to the tippy top, but you don't really. And the primary thing you were talking about, people now have to be aware of what I call manual load shedding. You're right. When you're running your hair dryer, you're not going to be, if you're on a limited size generator, you're not going to also be running your convection microwave. You have got to pick what any of the heavy amperage appliances are. And lithium batteries can, in fact, be a big chunk of that while it's running. So I've got a really good question here. Go ahead, Dennis. I'm sorry.
Yeah, I was just say easily 8 to 12 amps, depending on your charger. If you have a 60 amp or an 80 amp charger, very easily use 8 amps on a 60 amp charger. People running on generator, I generally recommend that they stick with the 60 amp or smaller. They may have to run longer, but if you have a 2,000 watt generator and you're using half that, it actually is usually only about 1,800 watts usable. And so you're using 8 amps of your 15 amps available. It's not a lot of power left.
Okay, so now I've got another question, and I've had this come from a variety of my readers. Here we go. Okay, from George Harding. Question: is there a benefit to using a second alternator in your vehicle? In my case, a diesel, and I've seen a number of these guys have added a second heavy-duty alternator just to be able to do these charges. Do you see that as a benefit, or is there a special version of alternator that you're aware of?
I think if you go to the Victron site, they do have recommendations for smart alternators. So if they have temperature sensing, and so if your alternator is getting too warm, it'll actually reduce the power output. Having a second alternator also, I've seen this in actually fire trucks and ambulances. Their house power or the rig power for the back end would run off of one alternator, and the engine and everything running up in the cab ran off the primary alternator. And so they were able to keep those systems separated, and if one failed, the other wasn't out, and which can often happen, especially if you're in a coach and you leave the radio running up in the cab, and then all of a sudden you can't start your engine. So I guess if you wanted to dedicate a system to that, then yes, and it won't take away from the chassis alternator as originally was designed. So I guess you'd have to look a little bit more into that. I'd probably have to talk to an engineer that is more involved with alternators than the experience I have.
Okay, so now I've got a product question for you. Let's see, here we go. So Jeff Suter, I guess. I have a PD4560 converter charger. I believe it is switchable between lead acid and lithium. Is that correct? Thanks.
Okay, all of the power centers that we have now have the capability of being switched from lead acid to lithium, either by a switch on the DC distribution board, like you would see on the 4500 series, the 4000 series. There's a switch on the charger board. On the 4100 series, there's a switch on the charger board as well. And so all of the designs that are currently being released do have a switch. There were some units, the replacement units for Wifco and Parallax, those have a jumper on board that allow you to change from the lithium 14.6 to the standard lead acid with the Wizard.
Okay, so here's another one here. Let's see. I have a PD, a 9180 ALV converter charger for my, must be battle-born lithium batteries. So it must have 4 of them. It is a single stage charger, 14.4 volts. Been told that lithium does not like continuous charge. Is that correct?
That is something we've heard, and we've actually been working with Battleborn, and we are starting to introduce 2-stage lithium charger. The charging voltage is not 14.4, it is actually 14.6. Actually, we kind of calibrate it down to 14.55. Some battery manufacturers don't want you to see 14.6, and trying to keep a tolerance on a mass-produced item more than or less than 1% is very difficult. You just have too many tolerances in the components involved in designing it. But we have a new design on the regulator, so we're able to keep that voltage much more even and not exceed some of the recommended voltages for the batteries. Even though they're in a general 2% tolerance, we're actually able to make that tighter. And after the battery is charged and certain qualifications are met, then the charger will drop down to a float voltage at 13.6. 13.6 allows some of the smart, BIM battery isolators, smart isolators that allows them to continue to charge a chassis battery at 13.6. So even if your chassis battery is a lead acid in the coach and you have a lithium for the house, that BIM will still allow that battery to get charged, and even at the lower voltage. So that's a plus there. It's currently in our 9160 ALVs. In about a month or two, we should be able to see that on the market in the 45 amp charger, the 9145 AL. And then following that will be the 80 amp. We are planning to introduce that into all the power centers. Power centers are a little bit more challenging only because we have to also include the standard charge wizard. We have a switch now to switch between one and the other, but we need to make sure that we have our current charge wizard profile for the lead acid batteries still functional and every bit as effective as it is now. And actually we may be able to make some improvements because we'll be able to monitor the current output of the chargers. So we've got the progression well planned, and we are taking the steps to ensure that we can meet the requirements of various battery manufacturers. Now, not all battery manufacturers say you have to go to a float voltage. So when you start looking at batteries, you get a lot of mixed information. So we've been progressively changing, but we're not making rapid changes just because we heard from this battery manufacturer, we want this and we want that. We can't do that. We need a charger that's going to operate your RV. And in addition, to give you the ability to charge various types of batteries. And that's the path we're taking.
Okay, so here's a question that one of my readers had sent in. What about low temp charging protection? Does the charger do it? Does the battery do it? What do I got to worry about if I'm in freezing weather and I want to charge my lithium batteries?
Okay, the lithium batteries, you can easily damage the cells, charging them at a low temperature, overcharging, undercharging. So lithium batteries are actually a smart battery. They have a built-in battery management system. It's a computerized system that monitors the individual cells in the battery. It monitors the charge coming in. It monitors the charge coming out. It monitors the voltage for the charge. And if things are not within certain parameters, it will shut down the battery. So your battery actually may have the capacity much greater than 100 amp hour on a 100 amp hour battery. But in order to improve and maintain long battery life, if you limit the amount of discharge and not let it fully discharge, say take it down to 10% or 20%, and not let it overcharge, then you have a battery that theoretically is capable of more, but is designed to work well within a comfort range to include longevity of the battery.
Okay, so this is a follow-up question. How much, I guess, PhD power can you remove from 100 amp hour lithium battery? Ah, the spell checks got us all. So that was, I mean, basically, how far can you go down safely with these things?
You can run them down to zero. The battery manager will tell you when to shut off. And so your 0 to 100% is actually regulated not per se by the battery or the battery cells, but it's regulated by the battery management system. So it will say, hey, you're not going any lower, because if you do, you're going to ruin me. And same for charging. You're not going to charge any more in me because you'll ruin me. And so there are protection parameters set up in the battery to maintain long battery life and keep the battery safe. Now, saying all that, you will see graphs and charts from various manufacturers saying that if you use a range between 90% state of charge to 30% state of charge, you may have a 5 or 10% increase in battery life cycle. Now, you have to consider that 5-10% increase or decrease. That's one lead acid battery over the life of the battery itself. You're still looking at exceeding, easily 10 years. And there are people that have worked in early lithium ion batteries, and you can see some of the YouTube videos, some of their mistakes, but overall, unless they did something wrong, those batteries are still running strong. And that's what people are really concerned about when they buy a lithium battery.
So now I've got another question here. So, okay, so Raymond asks, what is the correct amperage charger to charge if you have a pair of 100 amp hour lithium batteries? So if you had two of those things, what charger would you recommend?
Well, most lithium ion batteries charge at a 50% rate. So you look at the battery, if it's a 200 amp hour battery, they designate it as a 0.5 C or a half rate charge. So you'd be able to charge at 100 amps. Some of the battery manufacturers say you can charge at 100 amp on a 100 amp hour battery. Well, I don't know, on the average, most of the manufacturers say a half rate charge. So on a 200 amp hour battery, you could charge at 100 amps. Now, are you going to be able to plug it into the outlet on the side of your house that's 15 amps and charge with a 100 amp charger? No. You're going to trip the breaker or burn up the cord. So generally, if you can stay within that 60 amp charge, you can use that on a 15 amp circuit. You can use it with a 2000 watt generator, and it just will take a little longer to get a full charge into the battery. So at 60 amps, a little over 3 hours, that's a full charge on a 200 amp hour battery that's dead.
Okay, so
Not
I've
bad.
okay, I'm sorry.
That's
Good.
it.
Okay, so I've got two of them. I'm going to just put these right next to each other because, in fact, they're related. One's asking about, will a 7-pin trailer plug damage a lithium battery knowing a voltage loss? He's got a Progressive Dynamics lithium power center and solar controller. And then the second question is, sounds to me that if you do not have very large gauge wire all the way, you will have problems. So do you have problems if you try to hook this up with skinnier wire or whatever, or does it just take longer to charge?
Mostly it'll take longer to charge. If your wire is too small, you may not get a full 100% charge. As long as the wire is rated for the amperage, then there's no issue with burning up the wire. So assuming that in most cases, in most RVs, the customers I've talked to, they're running at least a 6 or an 8 gauge wire. And that will handle a 60 amp charger with no problem. However, if that wire is 30 foot long, you on a 60 amp charger may only be getting 25, 30 amps to the battery. It's going to take longer to charge. Will it hurt it? No. Putting a 5 amp charge on a lithium battery isn't going to hurt it either. Putting 13.6 volts and 3 amps of charge is not going to hurt the battery. You just may not fully charge the battery. And that would be the issue.
Okay, so T. Jenkins is asking, there's no such thing as a solar converter. They are solar chargers. Converter goes AC to DC. Solar charger is DC to DC. I don't have a lot of experience with it yet, but the solar charger things that I have seen, the ones I've played with at least, all look like they have some sort of a lithium setting on them, because that's going to be a popular thing, at least the modern ones that I've seen. Do you have any experience with solar chargers, Dennis, or?
Not personally, but I've worked with a number of customers that are using solar. The thing that I do know about solar is that it is taking that sunlight, converting it to electricity. It is basically an unregulated voltage. So the solar controller will convert that voltage to a regulated output. It is a DC to DC converter. And the term is converter, and that is proper. Charging is one aspect. The converting is another aspect. A converter charger is a charger that converts one type of voltage to a regulated output voltage and can be used for charging your battery.
Okay.
So no, there's no harm.
No harm. Okay, so I'm not Chuck says, how difficult is it to remove a converter from an RV and install a converter suitable for lithium batteries? So is this a DIY operation? You have to hire a technician? What do you think?
It depends on how agile you are. So sometimes these chargers are located under the bed. Sometimes they're buried in a closet. If you have a power center, it's usually on the floor. And I know for myself and many of my friends, getting down on the floor to work it isn't too bad. But if you have to get up and down, getting up gets harder every time. So you want to plan your job first. But really, it shouldn't be that bad. It's just where is everything located, and making sure that you're prepared ahead of time so that when you get down in the hole to replace it, you have all your tools. And as a field tech, that's one of the things you learn. Make sure you have your tools with you once you start the job so that you don't have to move around and go back and forth. And that makes your job go a whole lot easier.
Okay, so Mark Chapman, he's talking about a WFCO converter. It says it's got 14.4 volts in bulk mode, and it says seems it would charge almost as fast as 14.6 volts, but they say that lithium will only charge up to 80 to 90%. Does that sound right? If unless you can get full voltage out of the charger, that it won't take it all the way to the top. Is that correct?
So here's the issue. 14.4 will allow you to fully charge a battery. Actually, if you can get over 14 volts to the battery, you're going to get a full charge. And you're going to get a high rate of charge, whatever your converter is capable of. The problem with the Wifco charging system is, yes, it's a multi-stage charger, but in order to go into bulk mode, that battery voltage has to drop. The one thing about a lithium battery is the fact that it's got a linear output. You start out at a little above, maybe start at 13.2 with the load. It quite readily settles down to 12.8, and probably over 80% of your discharge, you're looking at a voltage of 12.8. It's pretty stable. It's not like a lead acid battery. You hit 50% on a lithium battery, you're not going to know it. You do that on a lead acid battery, your voltage is down to 12 too. So a lot of the multi-stage chargers will monitor the voltage, and when it sees that voltage drop below a threshold, it'll go into a boost mode. The factor with the Wifco charger is, yes, it has 14.4 capability, but you can't control it. So we do have a charging system, the PD 4135 series, which is actually has similar but also more capability than the Wifco charger. It's designed to go basically in the same hole, and we have many people switching one out for the other. The advantage we have on the current version and the newest version of the 4135 is the fact that we have added a lithium switch, so that if you're using it for lithium, you can set that lithium voltage 14.6. It's a fixed voltage. If you want to not worry about the lithium switch, say you only need it occasionally to charge the battery and you want to use the boost mode to do that, there's a button on the DC distribution board that allows you to manually go into boost mode. It'll stay in boost mode for 4 hours, and usually is more than enough time to charge the average battery. 35 amps at 4 hours, you're putting over 100 amp hours out.
So Jay Stump asks, would a PD 9280, would it work on charging a lithium battery?
Again, it's the same situation. The 9280 has a multi-stage charger, and it runs automatically, but it will not detect the lithium battery dropping below 11.9 or 11.7, because by the time the lithium battery is going to do that, it's getting ready to shut off. So by the time you get around to say, okay, it's time to turn the charger on, your battery's probably already shut off. If your battery is, say, at 20% state of charge, that voltage will be high enough not to initiate a boost mode. So again, you would need the remote control or the manual control of the Charge Wizard to be able to set it in boost mode and complete your charging, and in 2 hours you're capable of putting out close to 160 amps of charge.
Okay, so boy, you got all kinds of questions here. You're a popular guy here. Gracious. So this is a question for Dennis. You are calling for a PD91XX ALV. Is that as smart as the PD92 series that I have been installing?
So Matt, the 9100 series ALVs are in progression right now. So we do have a smart 60 amp charger. It has a 2-stage charging. It monitors the current, monitors the voltage, and makes decisions as to what charging mode it should be in. We've actually worked with Battleborn to come up with some parameters to work with. And we also take in mind some of the other battery manufacturers that we've worked with and information that we can gather from different companies online to come up with a parameter that is going to effectively charge these batteries, not keep them in a full charge voltage, but drop down to a storage charge. Like I said earlier, the 9145 ALV is the next product going to the 2-stage. We're waiting on equipment to come in, primarily the circuit boards. Once they're in, we'll start building them. We will stop the current line and go directly to a 2-stage charger on the 9145. After that, and we've already started doing testing, and I imagine the boards have been completely designed, the 80 will follow. In addition to that, that gives us the 70 amp charger, 30 amp chargers. So the deck mounts probably by mid-year will be completely 2-stage charging.
Here's another one here. Tom Prevo? Who knows? At what state of charge should a lithium battery be stored?
Okay, I've been told by a number of battery representatives that in general, a lithium battery for storage should be stored at about 50%.
I've
However,
gotten the
I was
same
reading
thing.
on
Yep.
one of the other one. Yeah, I was reading on one of the websites the other day, and they say charge it up and full charge and store it for a couple of months. Go back and recharge it again. Um, I'm going to err on the side of storing at 50%. And that's actually the same with pretty much any of the lithium batteries, including the lithium cobalt and those batteries that you may see in your cell phones and that. You don't have to force a charge on them all the time. I have not definitive information, but I've also read reports that keeping a full charge on the battery can affect chemical composition of the plates. So, and if that's true, then yes, you want to bring that voltage down for increased life of your battery.
Okay, so let's see. Do you have a general recommendation for the RVer for migrating to lithium from an AGM battery? They may have a charger already that'll do it, right? Go check it out first.
If they have a new charger, then and it's a power center, they will have the capability of switching over to lithium charger. Lithium batteries aren't for everybody. Number one, they're expensive, and many of us have a budget we work on. So if we're going that way, we need to really justify that we're putting out the expense for the right reason. So on someone that's plugged into a campsite all the time, you have to ask yourself, can I get a maintenance-free battery, and maybe I have to replace it every couple of years, but how often do I really use the battery? When I pull up to the site, put the slide outs out, level the rig before I plug into shore power. Pull everything in after I'm cleaning up and getting ready to the site. Or if there's a power outage while we're there, at least we'll have 12-volt lighting. You're not really getting much 12-volt use. Do you want to spend $1,000 for an hour, 2 hours a year of 12-volt battery? To me, that's not sensible. Where it's really a benefit, though, are people that spend a lot of time or even mixed amount of time between plugging in at a campsite or boondocking. When you're not connected to the shoreline, then you want a battery that will, number one, provide the power you want, work over a long time, be able to accept partial charge without going bad. And you can't do that on a lead acid battery. You need to get them fully charged in order to maintain a long life on a lead acid battery. The lithium, you have the advantage. You don't have to have a full charge. So you really have to judge whether you want to just have the convenience of, oh, I have a lead acid battery, or is this really a benefit for me? Or, hey, I can go to Walmart and get a maintenance-free battery, and if it dies in 2 years, I can take it back and probably get it replaced. Choice to make.
So one of my admins over who's over on my RVelectricity Facebook group. You guys enjoying that? And we have a lot of great guys on there. He asks, is there any benefit to the battery if it's disconnected while you're on shore power? That is, will your units operate properly as a converter and supply 12 volts for the RV, even if you have to take the battery out of circuit and have a disconnect switch?
So I know Battleborn makes a recommendation that if you're going to be plugged in for a period of 3 weeks or longer, to disconnect the battery. You don't need to put a full steady 14.6 volt charge on the battery. The converter will operate the RV. That's what it's designed to do. That's its first purpose, is to power the RV. The battery comes secondary to the primary purpose of running the RV. Now, early chargers required a battery for filtering. The modern chargers are switch mode chargers. They modulate a pulse into a transformer at a very high frequency. They are 30% more efficient or better, and much, much lighter. So there's a big advantage to the new style charger, and they do not require a battery to properly maintain or operate your RV.
Okay, so Jeff here, let's see, there's another question. So this is, I don't know that, did you answer this on the PD4560 already?
Yes,
I, you,
yes.
you did. Okay, so just double checking here. Um, so Gary Smith, so how can I upgrade to lithium coach batteries on my Mercedes Sprinter chassis that uses an AGM chassis battery?
So the question comes in is you don't want to use a lithium charger for charging your AGM batteries. Um, most of the Class C, Class B, Class A will charge the house battery from the alternator, but do not charge the chassis battery from the converter. There are some that can. I talked about a smart isolator, the BMI. Can't think of the name of the company. Um, and they have one for lithium, but I don't know if it actually drops the voltage. So if you are charging the battery from the alternator, either battery will accept some charge. If you're trying to charge the chassis battery from a lithium charger, then no, that's not recommended.
Okay, let's see here. So Kylie asks, have you considered putting a storage mode for lithium batteries? That is, manually set storage mode on the charger itself, and it will discharge the battery to a good storage level until storage mode is disabled? Something that would automatically take it down halfway? What do you think?
The problem with that is it requires additional interfacing. The current 9100s that are single stage actually have an add-on module that will allow you to shut down the charger. However, you need to know when to turn the charger back on. So you need a way to be able to monitor the battery state of charge, and at that point activate a contact to say, okay, I want to charge again. That's adding $300 to your charger just to have that feature. That's why we went to a two-stage charger and dropped down to a float voltage, which seems to be acceptable by all the battery manufacturers that we've had discussions with.
Okay, so Mike Zimmerman, the Z-Man from over one of the admins over on my Facebook group, says PD claims their IntelliPower converters have the lowest ground fault leakage in the industry. Can you use them on GFCI protected circuits without random tripping?
Well, that's a tough question because I've had a number of people call in and say, hey, I'm tripping my GFCI and I turn the converter off and I don't trip the GFCI anymore. I know that every unit that I work on in the shop, when I start going into test mode, and it's a full load test, whatever the amperage rating is of the individual converter, and I always test on a GFCI receptacle. And they get replaced every few years just because we're using them constantly. And the thing that we've found is that there's usually other things adding to the GFCI tripping, and it can be a number of things. You have water heaters that can have the casing leak, and so you're putting a voltage into the ground and not fully returning on a return. And even though you have the breakers off, the thing that people don't realize is that you've only opened up half of the GFCI circuit. The rest of the GFCI circuit is on the neutral side. So you could still have current flow through the neutral and ground and not have any current flow through the hot wire. And trying to detect that is a very meticulous process because you basically have to go and test with each branch circuit. And it's slightest bit more than what's regular. Yeah, Mike has a way to do it there.
I've got this new gadget I got from Italy, and this is like 18 or 20 bucks, and it actually has a breakout for the ground wire separate in it. And I found a little clamp on AC DC capable meter here. And this goes down to 1 milliamp resolution for like less than $40. So between these two things, you could start to figure out where those additive leakages are. That's the problem. This stuff all adds up. Everything leaks a little.
That's true.
Okay, so let's see. So I just have to show off my new gadgets. I'm sorry. So
That's okay.
let's see. So Rick came up with this. He says, my coach has 4 lead acid deep cycle batteries. How many lithium batteries should I replace the lead acid batteries?
Boy, that's a wide open question. So what you really need to do is plan your battery usage. You could put as many batteries as your vehicle will hold. Is there an advantage to it? No, you're spending a lot of money and not really utilizing them to their full extent. So if you have 4 batteries, is that 4 12-volt batteries at 50 amps, or is that 4 6-volt batteries at 250 amps apiece, and giving you a 500 amp hour battery bank? And if you want to do that with the lithium, you could do 400 easily with 2 batteries. Will give you actually more usable power than what you have in those 4 6-volt 250 amp battery bank.
Okay, so now let's see. My new camper is in production now. Likely has a 9145 AL when available. Can I upgrade to the 9145 ALD without replacing the power center?
You would have to replace the converter itself. Everything is done in the converter. So the PD 9145 would be the unit the 9145 would be the unit to replace. As far as the rest of your power system, your DC distribution, your AC distribution, that all stays the same.
Okay, so Raymond asks, how can a 60 amp charger operate when the shore power is only 30 amps? We covered this a little bit earlier, but can you give them the quick thumbnail sketch on that?
Okay, my basic answer is that you're mixing apples and oranges. The power is fruit, but the power coming at 120 volts at 10 amps is way different than power at 12 volts at 10 amps. It's a 10-to-1 ratio. So 30 amps of, like I mentioned earlier, a 60 amp DC charger requires 8 amps of AC voltage to operate. So that's far from that 30 amps coming in. You're using less than a third of your power to run that at full power, the charger at full power. You're getting 60 amps of DC out of 8 amps of AC. It's apples and oranges. Still fruit, but it's apples and oranges.
So here, you get a smiley face. Look at this. Brad says the existing
Right.
PD unit has worked great. Good work, and many thanks to everyone at Progressive Dynamics for their fine products. How you like that? Yay, yippee.
Great. Thanks, Steve. Thanks. Love
Thanks,
to
Brad.
hear it. We work hard on it. I work in service, so I interface with a lot of customers out in the field, and I hear that all the time. And when I don't hear that, and I'll look into why they may have a complaint. And sometimes when I go down to engineering, they kind of shrug their shoulders when I come in the door because they say, hey, we have to fix this. And it's a continuous process. We put out a new product, and sometimes it needs some tweaking. And as a company, we work hard on putting the best product out there.
Okay, so Sherry says, I skipped her question. I'm saving good stuff towards the end, Sherry. It's okay. So, but you smeared it across 2 questions here. So let's see here. She says, we have 2 250 amp hour lithium batteries, also 400 watts of solar panels, I guess, and a 2,000 watt inverter. If we plug into 110, 15 amp electricity while under covered storage for storage, will keeping it plugged into shore power charge with the trickle charger charging the batteries damage anything? So she's worried about I guess just when she's storing this thing, what should she do? Can she leave a trickle charger on the battery, or is that when you use the battery disconnect?
That's when you use the battery disconnect. Your charger will still provide 12 volts for the house. And so if you have a 60 amp charger, you'll be able to run all the 12 volt items in the house. And if you're plugged in, some of your 120 volt AC items as well. On a 50 amp cord, you're not going to run the air conditioner, but you can run small appliances. The battery, many of the battery manufacturers recommend for long-term storage to bring those down to 50% state of charge. So once you bring the battery down, you disconnect it. When you come back a year later, you're going to have pretty close to that 50% still in the battery. It doesn't leak internally like you see with the lead acid battery. So I would recommend disconnecting the battery for long-term storage. The only reason you need to keep the RV plugged in is so that you can operate your lights and other appliances in the RV.
Okay, so Brad says several years ago I replaced the power unit Magnatech 8300 with one from Progressive. What is the correct model to upgrade to that will support lithium charging? Upgrade from the
Okay, so
6345.
we have our 4600 series, which is replacement units for Wifco, Magnatech, and Parallax. The Magnatech, of course, is no longer in existence. And so we provide a DC distribution board, which may or may not be needed. It's definitely needed on the Magnatech. The distribution board allows for reverse battery protection to keep from damaging the converter if there's a miswire at the battery. Our DC distribution board also has control for the charge wizard. However, and they are all capable of being strapped to a lithium charge mode. When you're using our converters in lithium mode, the charge wizard is disabled. So you don't need to have remote control for it. It's not going to do anything. It's just going to sit there. You're getting a straight 14.6 volt out. It's available in a 35 amp, 45 amp, or 55 amp, and it will mount in place of the existing converter section in any of those units.
Okay, so here's more love. I dealt with Dennis previously and was pleased with the service. Glad my new truck camper has a Progressive Dynamics power center. There you go. Unsolicited
Thank you, Rick.
testimonials.
Great to hear. Thank you.
Okay, so now I've got another one here from Brad Wortman. I do a lot of boondocking. I saw a DIY build for a 280 amp hour lithium battery using 4 3.3 volt cells for a total of 13.2 volts and a battery management systems. What's your experience with DIY builds versus buying from a commercial vendor?
Brad, the thing that you have to realize is that if you are going to build a battery, you need to really know what you're doing. Most people don't have the time or the background to do the research to make sure that when you build this battery, it's going to be safe. It's going to operate within parameters that won't damage the cells or cause any physical harm to the rig or anybody in the rig. So a production-made battery has a BMS system. Many of them are quoting either UL approval or automotive quality approval, which means they meet certain safety standards and operational standards. And so I generally recommend that you get a battery that is factory built. Now, if you have the expertise, and I've seen some videos with people that have built battery banks and have done extremely well, took a lot of research on their end, in some cases, experimentation and failures. If you're ready to take that on, that's fine. But for the average camper, a drop-in battery and a proper charger is what they need.
I would agree. I engineer a lot of stuff, and to build, engineering and building a one-off is never going to save you money. The best thing you can do, and to go with somebody that's actually tested these things, and also you have the liability considerations. in case you do something silly that catches on fire or damages things. There's no recourse. You become your own manufacturer. So yeah, I never recommend anybody put something like that together unless you are really, really smart at that. And I mean like smarter than me, because I won't do this. Now this is an interesting question. So Van Lee RV have resettable fuses. Is it a good idea? If yes, why doesn't everyone else use them? So you're talking about resettable fuses in the 12-volt side of things.
Most common resettable fuse that I see or hear complain about is the battery protection fuse. It's usually located within 18 inches of the battery. It is designed so that if your battery cable gets short circuited in house, it'll protect the battery. It'll trip, it'll reset and trip and reset, probably go bad, but it'll keep you from having a battery that explodes. Usually they are rated for 30, 40, 50 amps. And for the most part, in most RVs, that's plenty. However, when you have a 60 amp charger and a 40 amp short stop breaker or auto resetting breaker, thermal breaker, however you want to term it, when you start charging at 60 amp, that circuit breaker is going to trip, reset, and burn itself out. And then you don't have any charging. That is one of the biggest failures that I hear from my customers calling in. I put this brand new charger in, I put this brand new battery in, it worked for a week, and now my battery runs dead and I have to use another charger to get it charging. It's usually the breaker. I generally recommend a manual resettable breaker, something similar. Blue Sea has a number of them. Blue Sea Systems. Buzzman has a CB 185 series. They have some other series. The thing that I recommend is number one, that it's rated for at least 120% of the charge rating. So a 60 amp charger would require a 80 amp circuit breaker. Number one, if it trips, you can reset it, but you can determine first, why did it trip? And if you made a mistake and you trip it again, well, you're not hunting all over the RV for an extra fuse. Because let's face it, those T fuses are expensive. Those maxi fuses are expensive. How many of them are you going to carry? You can only make so many mistakes before you're out of luck. So I recommend the circuit breaker. And the other thing too is that most often these are in the battery compartment. Now, granted, lithium batteries do not gas like a lead acid battery. However, you have a designated battery compartment. I always recommend you use a breaker that is ignition protected so that if it trips and sparks, it will not cause an explosion, because when you sell your RV and after spending all that money on that battery, believe me, you're going to take $100 and put a battery in and say, hey, buddy, you're on your way. You want a lithium battery, go for it and buy it yourself. Because number one, that battery is still going to last you. You're going to take it with you. It'll last you an RV or two or three.
Okay, so Snoopy's got one. We got time for a few more. You got time for a few more questions here, Dennis? Yoki dokie?
Sure.
Okay, Snoopy, 2 Jeeps. Mike, I read that with a state of charge meter monitoring lithium batteries, and after they reach 0 volts, I guess 0 charge, that the state of charge meter keeps on drawing current and would destroy the lithium batteries. Is there any truth to that? So basically, if you have a state of charge meter on there and your battery runs down to 0, will the state of charge, will your meter just continue to draw current from the battery and just eventually wreck it once you get down below whatever they consider 0?
Actually, the BMS should shut off the battery when it reaches 0. So there is no charge coming out of the battery.
Yeah,
so
that's
no
what
power.
I've seen. When they hit 0, they just say no more.
And yeah, I ran a couple batteries down last week and doing some tests and ran them down to 0. And then I pulled all the load off and put a light load on it, and it powered it for a little bit. The BMS is working, but it said, I still can't even operate that kind of current. So it will shut itself down. So what it's supposed to do.
And Steve asks, is there any downside of charging a lithium battery using my PD4655L in its normal configuration and not using the jumper to put it into lithium mode?
So Steve, again, we're at the point of, okay, we're using a standard multi-stage charger. So at the normal charge rate at 13.6, you will put a slow charge into the battery. Most battery manufacturers don't recommend it because you probably won't get a full charge. You'll get pretty close. You could probably get 90%. You might do a little better. It'll take forever to get there. So charging at a slow rate may take you 8 hours to do what you could do in an hour and a half at a rapid charge. But if you manually select boost mode, either with the pendant or with the button that's on the DC distribution board, then you can charge at 14.4. So when you need to actually put a charge into the battery, then go ahead, press the button, charge the battery up full. Meanwhile, if you're not worried about using battery power and your battery's not sitting at full power, you don't have to worry about it because you're not damaging the battery by being undercharged. That's a nice thing about a lithium battery.
Okay, so another one. I understand that flooded lead acid batteries, when they're connected in parallel, they must be properly matched for age. Is this also true of lithium batteries?
I think there is still some truth to that. And it's also not only just because they're matched batteries, it's also how you wire them together. So you have two things going on when you have matched batteries. Number one, they're going to be probably a similar cell set, so they're going to act the same. So the current draw on either set cells, one battery bank versus the other, is going to be the same or very, very similar. If you go to a different battery type or even a different battery amperage, you may see an imbalance there. The key to using any parallel batteries, though, is you connect the two batteries together. Your chassis ground is on one battery negative, your charging is on the other battery positive, so that and keeping the wires short between each battery. That way you have a physical, natural balancing between the batteries. And yes, they should be preferably the same lot, the same age, the same ratings. And then no single battery has to take the brunt of charging or discharging. And if you daisy chain them down the line and put your charging on one battery and your negative on the same battery, that means every other battery down the line is getting a little less and a little less. And so I would follow that same practice with the lithium, although I really haven't read anything specific about it, but to me it just makes common sense.
Okay, so okay, one more here. I bought a PD lithium charger module to pop into my PD 4590 power panel. If in the future I install a Victron inverter charger, do I need to disconnect the charger in the PD 4590?
That's kind of a yes and no question. Part of it is what are you powering with the inverter? We generally don't recommend this, but some people will power the entire power center off of the inverter. And if you do that, you have to disconnect the charger. You cannot have the inverter charging the battery that's it's pulling power from. It's a vicious loop. There is no such thing as perpetual motion, and you'll lose about 30% of the energy. You waste it. It just goes right out the window because you're charging, discharging multiple times with the same source. It doesn't work. If you are using and feeding a sub panel, which is what we recommend, off of the inverter, then those circuits that run off the inverter will also run off a shoreline if it's set up properly. But at the same time, if you lose shoreline or your generator, the air conditioner won't fire up. Other things may not work as well because you've limited access to the battery supplied 120 volts. In that case, really doesn't matter. The chargers can aid themselves. The question that I would have is, are you going to on a lithium battery exceed the recommended charge rate. So if you have a 90 amp charger and a 100 amp charger in the inverter, and you have a 200 amp hour battery that should probably be charging at a rate of 100 amps, I would only use one charger.
Okay, so we're just going to take one last question here. So Peter, and I am not even going to attempt this last name. I bought a PD9160 ALV. Is the charge voltage the same as supplies to the house 12-volt system? I guess he wants to know does the house voltage vary it up and down with that as the battery voltage varies up and down while it's charging?
So the house voltage follows the converter charger. Like I said earlier, number one, the purpose of the converter is supply power for the house. In addition, it has the capability of charging the battery. And so, yes, if you're at 14.6 on your charger, you're supplying 14.6 to the house. If it drops down to 13.6 on a storage charge on the dual lithium chargers, then you'll have 13.6 in the house. And if you turn the converter off or remove your shoreline, you have battery power only. It's all connected together. It's like a big grid inside your RV. The 12 volts going from the battery to the converter to the DC distribution panel, think of it as one huge transmission line. Everything is all connected together.
Okay, and then just two final quickie things here. Nora said, I had to join in late. Will Mike be posting this as a viewable file on YouTube? Yes, indeed. In fact, it's going to be there right now as soon as they finish killing it. As soon as running the thing through its little processor. And then I'll post it on my website. I know Dennis will also be doing some of this. And Paul says, what a great session. Thanks to both of you for a great Q&A, especially the detailed answers. And so all good stuff. Okay, Dennis, do you have any last words of wisdom for these guys before we sign off?
I think for words of wisdom is do a little homework when you decide to purchase your battery. Don't just say, oh, well, this one's $500, this one's $900, I'll buy the $500 battery. You might not be getting a $900 battery for $500. So you want to do a little research, make sure that your charger is capable of operating within the parameters. Each battery manufacturer does set their own parameters there. But the other thing too is I do appreciate everyone that's joined us. I think there's been some very good questions. Being able to broadcast to a large group of people, in a sense, makes it easier for me because I can take care of all these questions at one time, not as individual phone calls. However, I have a suspicion that may generate some more phone calls anyways. So I don't know if I'll gain or lose on that. I don't know how that'll work out. But Mike, I really appreciate you having me come on board for this. I know I've been following your articles for quite a while now. And I think your approach to helping your followers understand RV electricity is very important. And I'm right on board with that. And thank you very much.
And thank you, Dennis. You know, you're one of the guys I have on speed dial. If I have some crazy question, I do. I've got engineers all around the world on speed dial, which I think is just fabulous. All right, we're going to sign off. You can still leave some more stuff in the comments section. I'll leave that open and we'll take a look at it later. And then perhaps if we have some more advanced questions at some future time, we'll invite Dennis back on. Let us all know how you like this, and I'll post links to this over on my various other groups here tomorrow. All right. Thank you all for attending. Dennis, thank you very much for your time.
You're very welcome, and good night all.
Good night, everybody.